I hope you enjoy the following class. Do realize all of these video classes are based on what I teach at Silicon Dojo here in Asheville, North Carolina. These are free to the end user, hands-on technology classes where basically you just sign up, you show up, and you get to learn technology. I will remind you that free to the end user is not actually free. All of this stuff costs me a shocking amount of money. So if you would like to support the educational programs that I am creating, the education that I deliver, please think about clicking on the donor box link down below and throwing a couple of dollars in for the cause. I hope you enjoy this class, and more importantly, I hope to see you at Silicon Dojo sometime in the future. Welcome back. As you know, I am Eli, the computer guy, and in today's class, we are going to go over how to use the National Weather Service REST API with Python. So when you go out and you start building your projects with code, you're going to need to figure out what data sources are important for you, right? This might be a database that contains records, invoice information, client information, that type of thing. It may be APIs, so basically being able to do an API call out to some kind of service and be able to get a response back so that you can do something with that response. One of the things that I think is interesting is the National Weather Service. Why this is interesting is because this is a free API from the United States government for the United States that gives you weather reports, and more importantly, it gives you weather alerts, right? So in the modern world, we hear a lot about augmented reality, right? And when people talk about augmented reality, it's always this Terminator crap, right? You watch these sci-fi shows and people have, text and images superimposed over their vision, and honestly, it makes me a little nauseous to even watch those television shows. I cannot fathom why I would want that in the real world. I do understand why additional information is important, giving me information about my environment that I may not know on my own. That is a very powerful thing. Again, having text scrolling across your actual vision, that just seems like a recipe for a headache. I think about this when I think about augmented reality. When my wife and I traveled around the country with our travel trailer, so we had an Airstream, and when you have a travel trailer, there are GPS units, not just simply your smartphone, but there's dedicated GPS units that track a whole bunch of different information that your smartphone normally doesn't track. Things like elevation, descents, basically what the grade is in an area, where truck stops are versus specific gas stations. There's just a whole bunch of different information, and it was very useful for me. So I'd sit there driving my F-150 and I could stare ahead and I could see the road and all the road signs and all that kind of stuff. I could see my speedometer and all that kind of thing. And then over on the right hand side, I'd have this Diesel GPS unit, and that would provide me additional information about my environment. Again, things like grade. So when you're towing a trailer, and you may not actually realize it, you feel like you're on a flat ground and you're actually declining. So you want to make sure you don't speed up too much or do something stupid with your brakes. The other thing that I also liked with it is it would tell you where truck stops were. And so as I was driving along at hopefully 10 miles a gallon, when you go out there and you start towing a travel trailer, oh my God, the miles per gallon is absolutely brutal. Anyways, when I'm trying to calculate how far my vehicle can get, it's like, well, it's a 26-gallon tank. It looks like I'm getting 8 miles per gallon right now. How far can I go? One of the cool parts is I could just press a little button and it would show me in order all the truck stops in distance away. So the next truck stop is 5 miles away. I want to wait a little while. I don't want to get off the road quite yet. The truck stop after that is 30 miles away. Okay, that's a little bit better. And the truck stop after that is 100 miles away. And so I could very easily just get additional information about my environment to say, I'm not going to stop at the next truck stop, but I will stop at that 130 miles away because I don't feel comfortable for my vehicle getting 100 miles with the current gas tank and the miles per gallon that we're getting, right? That's the kind of thing we think about, or that I think about when I think about augmented reality. Again, giving me additional information about my situation so that I can make real-time decisions. Why this is important when we start talking about the National Weather Service is that this can give us weather alerts, right? So you may be used to API calls or whatever else with basically getting normal weather forecast. Hey, it's going to rain today, or hey, it's going to be sunny. This is the max temperature, this is the min temperature, all of that kind of stuff. And that's very useful. But think about this. What if you had a company where your employees were out in the field? Maybe it's construction, maybe it's landscaping, whatever, right? You have 100 employees in the morning, you give them their orders, and they go off to all parts in your county or your state. Well, one of the concerns there is what happens if a tornado pops up? What happens if a storm moves in, something that was unexpected? Would your people know about it, right? If you have an employee on a construction crew and they're deciding whether to go a couple of stories up in order to do something, would they know that a storm is moving through, high winds are moving through, and now may not be the best time to go go on a ladder and go 5 stories up, right? So one of the cool things with the National Weather Service API is you can actually write code so that you can constantly scanning for these weather alerts. If a weather alert comes up, then you can trigger an event to occur because of that. So today, by the end of this, I'm just going to show you how to build a little HTML web page because that's simple. This is a pretty simple class. But if you were using something like Twilio, so Twilio is an SMS messaging API, you could have where all of your people are out in the field. If there is a storm warning, all of your employees could get sent an SMS message to say, hey, a storm is coming through, right? That's a useful thing. If they're using, if they were getting email notifications through SendGrid, you could actually send an email notification to people. You can actually send verbal communications. Again, using different API calls, you can actually send voice communication to actually send a message directly with a telephone number. Essentially, you're robocalling your own employees with your own specific message. So again, imagine if your people are in the field, a storm is coming through, everybody gets a nice little SMS message to say, please wrap up the work that you're currently doing so the customer is happy, right? So wrap it up, look all professional, and then go grab a cup of coffee because it looks like the storm will be here for about 2 hours, or do whatever else, right? Think about how that provides your employees information about their environment that they may not necessarily know, and think about how you can then build systems that have value for your customer or client so that their operations can run much more effectively. So again, whether it's the National Weather Service API, whether it's actually like a weather API, all kinds of different APIs are out there for communication, for being able to find out this kind of stuff. And so basically what I'm going to be showing you how to do today is how to parse this National Weather Service API, how to interact with it so that you can do some pretty cool stuff. So the first thing is to find the National Weather Service API. And of course it's the government. So they're not just going to say nationalweatherserviceapi.com, now will they? No, that's not what the government does. So anyways, if you're trying to find this API, the easiest thing to do is simply Google search National Weather API. You should see this, nationalweatherservice.gov API web service, and you'll see the link is this weather.gov documentation, blase, blase, blase. If I click on this, then we are then going to come again to the National Weather Service API page. Again, we have the API web service here. It gives us a bit of information about this API service. And the good part is that it's free. Again, so this is actually being provided by the government. You get this for absolute free. I don't know how many requests you can make per second or whatever, but most likely for whatever it is that you're trying to do, you should be good. If we go over, we take a look at the examples. The nice part about this, not only is this free, but you also do not have to create an account, right? So if you go out there, you look at a lot of API services, private API services, they make it quote unquote free as long as you give them your email address. And then, surprisingly, for some reason, you start getting the crap spammed out of you about 5 days later, right? The nice part about this, you don't have to worry about creating an account. You don't have to worry about API keys, any of that kind of stuff. Again, this is just basic open information. If we come down here, we can see there's some different ways that we can pull the information. So the first way that they're going to tell you is by grid location, right? So the National Weather Service has these things called grid. Forecasts are created at each NWS Weather Forecast Office on their own grid definition at a resolution of about 2.5 by 2.5 kilometers. Honestly, I have no idea how grids work. Apparently, grids exist. They use grids. I do not use grids, and so this is here. I am ignoring it. The first one that we go to, though, for the API call that is actually useful is to make this what's called a REST API call, is you go to HTTPS api.weather.gov points, you give a latitude and you give a longitude. And so this will give you the weather information for your specific latitude and longitude. So this could be useful if you have the actual address information for where your employees are going. If you have the specific address information, you can pull that latitude, longitude. With your smartphone, there are something called HTML5 APIs for JavaScript. So if you ever go to a web page and it asks you if you're willing to provide your location to whatever web page that you're going to, that is actually an API call that is able to access your GPS literally on your smartphone and then be able to send the latitude, longitude just as you normally would, right? So the latitude and longitude can be very, very valuable, but you will have to try to figure out how to get the specific latitude or longitude. The first thing that I'll be showing you today is how to get the alerts actually based just off of state, right? So if you're just has filters for alerts, so again, whether basically a storm is coming through, riptides, whatever, that kind of thing, with this HTTPS api.weather.gov alerts, active, area, and then your state, make it uppercase, the letters. So uppercase NC. I'm in North Carolina, so uppercase NC. If you're in Florida, uppercase FL, that type of things, right? For example, as they show right here, api.weather.gov alerts, active area KS for Kansas, and so it will give you those alerts. Now this is what is called a REST API. So we've been doing a lot of stuff with OpenAI, other types of APIs out there where you actually have to install modules or something onto your computer in order to interact with their service. The cool part about REST APIs is basically this is just a web page call. You're going to a web page, you're providing certain variable values, and then the web page is being dynamically written for you as either text or something called a JSON format, basically a data format. You're then able to grab that text and do with it as you will. So basically, when you're using a REST API, you know how if you go to a WordPress website, that WordPress website is dynamically built for you, so you can see the news or whatever the latest post, that type of thing. Well, think about a REST API call is essentially that, only the response looks like this, right? So with this, I don't know if you can see it up here, api.weather.gov alerts active area equals NC. And this is what you get for it. This shows you the context. This shows you some different information. And basically what happens is this text is sent back to your code in Python, and then you're able to parse this text and do something useful with it. So this is what we talk about when we're looking at a REST API. Basically think about it, again, like a dynamic web page, you know, without all the multimedia stuff. There's no pictures, there's no images, there's no CSS, there's no JavaScript. There's just a whole bunch of text. So this is the first code example that I'm going to be walking you through today. So basically I have this open up in VS Code. My lab computer is an M2 MacBook Pro, but everything that I'm showing with you today basically should work on everything. If you have Ubuntu, if you have Chromebook, if you have Windows, basically anything that would have Python 3, we're not doing anything special. We are not installing anything with pip 3. There are no additional modules outside of what comes with Python, you know, basically out of the box. So this should work on whatever you're going to be using. You will notice there are some things commented out here. And the reason that I've commented these things out is basically so we can step through this code. I can show you some different results and again, how to pull out information relatively easily. So when we take a look at this, the first thing that we're going to do is we're going to import the requests module. So the request module allows you to go out to a URL, allows you to go out to a web page and basically pull the information from that web page back to your script. right? Here, I'm going to make state equals NC, so state equals North Carolina. Put that there just as a static variable. So response equals request, so the request module, get, right? And then what we're doing here is we're putting in the URL as an F string. So with an F string, we're able to put variable values in here. So we just simply do F, single quotation marks, again, https api.weather.gov alerts active question mark area equals, and then this will dynamically plug in whatever state that I tell it to plug in. And then I'm doing .json, right? So up until here, if I make this response and then I try to print the response out, it is simply going to print out as an object. Yep, you got an object. That is not actually useful. So by doing this .json method at the end, what I'm doing is I'm turning this object, basically the response that I'm getting, into JSON that I'm able to interact with. So if I want specific variables out of the JSON that I showed you before, I'm able to pull out those variable values based off of the index. You could do .text at the end of this. Everything would come in as a text file. But then it's just text. You're not able to get to the indexes or anything else. So once that is pulled in, we can then do print response, and this will pull in everything for us. If I then go and I run this, basically this is what the response then looks like. So this is when it started running. Context basically equals this information, features, ID. And this is ugly. This is hard to deal with. Now, to be clear here, you can actually access all of these keys as it is right here. Everything works fine as JSON. The problem is, especially when you're new to any of these APIs, you're going to look at this and be like, oh boy. Okay, so context. Okay, well, that's a list. That's not what I want. Features. Right? It's difficult to go through this and understand what this looks like, right? So basically what we can do is we can go up here and we can import the JSON module. So I'm going to uncomment out the JSON module. I'm going to comment out that print response that we did before. And then I'm going to create a pretty JSON response. So response, pretty, oh so pretty and witty and wise, right? We want a pretty JSON response. We ain't dealing with no ugly JSON responses around here. Anyways, equals the JSON module, the dumps method. We feed it the response that we got, right? That JSON response that we got, we feed it that, comma, indent equals 2. And what this is going to do is when we print this out, basically every layer within that JSON that we got back will be indented by 2, so it's going to be a lot easier to read. Then we're simply going to print response pretty to see the pretty response. So when I do this, now we can see this is basically a pretty response. And it's a lot easier to figure out what's going on here, right? We have a lot nicer formatting, so it's a lot easier to come through. Okay, so this is when we run the code. Okay, so I don't want context. I do want features. And then from features, I can go through here and find the information that I want. The area being described is Maryland beaches. I can come down here. Oh, it'll show me sender name, so headline is beach hazard statement issued September 20th. Description is what for, beach hazard statement, the whole 9 yards. So now I'm able to go through and I'm able to pull out that specific information, right? So basically, I can close this and then I'm going to basically comment out that. I'm going to comment out that. And so I'm going to then uncomment out this right here, right? So response equals request.get, the API, and then what we're going to do down here is a for x loop. So in response, in features, I then want to print properties, area described, properties, headline, properties, description. So what this is if there are multiple alerts, we are going to loop through those multiple alerts, say where the area is that the alert is for, we're going to say what the headline is, and we're going to say what the description, then we're going to print out these these little stars with next lines so we can see a division, and so we're going to be able to print that out. When I go and then do this, so now we get something that's a lot prettier here. So Maryland beaches, Eastern Currituck, Virginia Beach, Northampton, all these, what, beach hazard statement, where, Maryland beaches, North Carolina, Eastern, blah, 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 right? So this actually gives me the alerts that I care about and the specific information. So there's a whole bunch of different information in that JSON. I can pull out the specific information that I want. If I go here and let's say I change this to Florida, so FL, this will give us a little bit better response. Let me go through, let me do it. And basically if we go through, we can see that they have lots and lots and lots of warnings. They have like 5 warnings or whatever here, right? So we keep scrolling up. We can then see, they actually do have a few warnings, right? Ooh, they have more warnings than I thought. My golly. Seriously, how many warnings? Okay, so this is where it starts. What's the area? Brevard, Florida. Osceola, Florida. Flood advisory issued September 20th at 4:16 p.m. Flooding caused by excessive rainfall is expected, a portion of the East Coast. And so basically, right, all of this information is coming in through the API call, and then you could do additional parsing on this to determine which one of these warnings actually matters for your company or for your employees out in the field. So this is the basic way you can simply use a state to be able to pull these National Weather Services alerts and then be able to pull the specific information that you care about for each alert. So that code example that I just showed you had you statically assign a value for the variable. Florida, North Carolina, Maryland, wherever the hell you're at, you statically put that in there with the idea being that you're not going to be moving around. But here's the thing, right? We're geeks. We're coders. If you can do something statically, that's for the normies. We want dynamic stuff, right? And so one of the questions is, how can you dynamically figure out what your geolocation is so that you can feed it into the National Weather Service API to get something a little bit more specific. Now, again, if you do have a smartphone and you want to go into the JavaScript world, again, there is that HTML5 API that allows you to pull the compass, or not the compass, the GPS readings from your smartphone and be able to send that to a web server. That's a little bit more than I want to deal with today. So what we're actually going to be dealing with today is a lesson that we did pretty recently, where we're going to pull our external IP address for our computer. We're then going to get the geographic information about our external IP address from a database that contains that type of information. We are then going to pull the latitude and longitude out of that geographic information that we get, and from there we're actually then going to write out a little HTML5 or an HTML web page to show us what the alerts are. And so this is a good example of an incredibly simple script. This is a stupidly simple script that I'm showing you folks in a stupidly simple class. But you can start to see how complicated code can get, where we're using one API call to feed another API call to feed another API call to then export to some kind of data store right here. And again, as this goes, this gets much, much more complicated as you create more complicated projects. So with this, we're just going to import requests. So we're not going to make JSON pretty. Again, in order to interact with JSON, it does not have to be pretty. In order to figure out what the hell the JSON is telling you, sometimes you do have to make it pretty. So we're not prettifying the JSON here. So we're doing the import request. First thing that we're going to do is we need our IP address. What is our external IP address, right? So if we have a computer, my computer has the internal, is on the internal network, and when it goes out to the internet, what is the external IP address? I want to pull that in, right? So request.get There's the api.ipfi.org, and I'm bringing it back simply as text, right? So in a previous class we did that. Basically, all this API does is it literally simply returns a text value for what your external IP address is. We're then going to print what our IP address is just to verify that we get it. Now we need the geographic data. Now, geographic data about all these external IP addresses basically resides within databases. So all of this information is relatively well known. There's a lot of different API providers out there that can give you information about specific IP addresses. And so we're going to use IP-API because they're free, at least for educational purposes. So geodata equals request.get fstring HTTP ip-api.com JSON, and then whatever our IP address is, .json. I will say, when I was teaching classes about this type of thing at Silicon Dojo here in Asheville, North Carolina, one of the interesting failures that I've seen is do not put HTTPS. It is HTTP. If you put HTTPS, for some reason, it will not provide you a result. The rest of the script fails. So do make sure it's HTTP for these, not HTTPS. So we get the IP address. We then get the geographic information about the IP address as JSON. We are then going to print out that geographic data because it's pretty simple to see. That's not too complicated to figure out what's going on. From here, what we're going to do is from geodata, we're going to get the latitude. So there's going to be an index for lat. We're going to get the value and put into the lat variable. There's an index for long, for the longitude. We're going to put that into the lon variable. And then we're going to print out what our latitude is. And we're going to print out what our longitude is. Down here, we're going to come and we have response. So this is where we get the alerts for the latitude and the longitude. Response equals request.get api-weather.gov alerts question point equals lat, comma lon, and again I want that to come back as a JSON value so that I can parse it, that I can deal with it. Print. So this is going to print out on this screen, basically on the command line, alerts, and then it's simply going to print out how many alerts that you're getting. So the length of response features. So features basically is a dictionary beyond this, and so this is where all the additional alerts are. So what this is simply going to do is it's simply going to say how many alerts am I supposed to be seeing? 1, 2, 3, 4, 5, 50, something like that. That's what that length right there is going to do. Then down here, what we're going to do is we're going to export into a type of data store. Again, we're going to do something simple. We're just simply going to print out to an HTML web page so that we can pull this up in Firefox. So file equals open alert.html W for overwrite. It will either create the file or overwrite the file that already exists. For X in response features, so basically all the alerts, right, are under features. We're then going to do file.write, essentially H1 X properties headline. So what we want to do is we want to print the headline for this alert, or we want to write the headline for this alert into the file. File.write H3 properties area describe. So this is the area that the alert pertains to. So we're going to write that as an H3, so a little bit smaller. Then file.write properties description in p tags. So basically a description underneath. And then external to this, we're going to close. So we open the file. We loop for as many alerts as there is. We keep adding to that file. And then when we get done, we close the file, and then we should have a little HTML document, right? So if I, let's see here. Okay, so if I do this, I'm actually using VPN right now. So my VPN says that I'm in Atlanta. So I actually did that so I can get some different alerts here, right, dynamically. So if I run this, what are the alerts for Atlanta? Right? So we had a whole bunch of prints. So this prints out our IP address. This prints out the geographic information about our IP address. We print out our latitude. We print out our longitude. And then we print out how many alerts. So we have 3 alerts. This is then going to store that little alert.html in our home directory. So wherever your user account is, whatever the home directory for your user account, it will be stored there. So I'm going to pull this up and we can see alert.html is in the Eli directory. When I pull this up, I'll make sure to refresh. Okay, there we go. So for Atlanta, again, severe thunderstorm warning issued September 14th at 2:37. For Clayton, DeKalb, or Fulton, the storm which prompted the warning has weakened below severe levels, so on and so forth. Severe thunderstorm warning at 1:55. The National Weather Service in Peachtree has issued severe thunderstorm warning for all of these areas. And then down here, a special weather statement issued for North Fulton, DeKalb, and Clayton. Again, damage to tree limbs, blowing around light, unsecured objects. Heavy rain may cause temporary street flooding, especially in poor drainage areas. Again, wouldn't that kind of thing be important for you if you have a crew out in the field? If I go up here, again, to my VPN service, let's change over to Miami, because it's always more exciting in Miami, at least as far as disasters are concerned. Miami is more exciting. It's like, yeah, well, because they have more disasters. Anyways, from here, let me pull up the code. So now the VPN makes it so it thinks that I am now in Miami instead of Atlanta. I'm going to run this exact same script. We can see I have a new IP address because I'm going through the VPN. We can see the city is Miami, latitude, longitude, and now we have 5 alerts. If I go over and basically I do a refresh of the alert.html, we can see these different 5 alerts. Special marine warning issued. All these different areas, National Weather Service, coastal waters, blah, blah, blah. Water spouts, wind gusts 35 knots or higher, small hail, source of radar, special marine weather statement, and all of this type of thing. So again, imagine if you put something like this on your server, every 10 minutes or so it fires off. You have your script looking for specific information, again, specific locations where your people might be out in the field, different types of warning, that type of thing, and then you can send off something like an SMS message, basically to make sure that your employees try to remain safe, and you know they don't make a disaster of whatever job it is that they're working on. Again, if they're doing construction or landscaping or that type of deal. So that's basically the code for today. Oops. Again, all of this is relatively simple. Again, these are just simply a REST API calls, and this kind of gives you an idea how to use the National Weather Service alerts in order to build something that might be, functional for your particular environment. And so that was the class for today. There's not a lot to the National Weather Service REST API, but I do think it would be useful for a lot of folks, again, designing, applications or platforms for companies or for organizations that have people out, in the field doing work. This is able to give you alerts about specific areas, and then with that information, your users are able to make the best decisions, which is the good thing, right? I think that's one of the sad things, like so many times in the modern world nowadays, when people start talking about artificial intelligence, or when they talk about computers, and they talk about managers using artificial intelligence or APIs and computers and all this kind of thing, basically it's seen as a negative for the employees. The more technology that your company implements, the worse it is going to be for you. And what's really sad is there's a lot of these useful services out there that could actually make your employees' lives better and make your company more profitable, right? Again, I've had enough construction done over the years. I've hired enough contractors. One of the worst things is when they're, hammering away at your house or hammering away at a building, and all of a sudden the storm comes through and it's a complete and utter crap show. Wouldn't it be nice if they got a little alert, again, saying, hey, why don't you pack everything up? Why don't you seal up the property that you're dealing with, and basically call it a day or do whatever else to wait for the weather to go through. That will make it safer and better for your employees. Your customer is going to be happier because you're not going to see the employees running around in the middle of a damn rainstorm. And again, it may actually save your company money if you don't have to fix damage because, again, walls or something were open when a rainstorm hit. I had a property I was spending a lot of money in order to renovate a number of years ago, and that's what happened, right? They were out there, they cracked open a lot of that house, rainstorm came through, and their company got a nice little bill for it because there was damage done to the inside of my house, and basically it was because they didn't have things sealed up properly. And so again, having things like this, Again, it should be win, win, win. It makes everybody's lives better. So again, that we can just do the work that we all want to do. And so that's the idea here. Again, it's free, it's easy to use, blase, 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 blase. So with that, don't think there's anything else to say. So as always, I enjoyed teaching this particular class, and I look forward to seeing you at the next one.